What if reality isn't stable? What if it only looks normal because we can't see fast enough? These scientific phenomena prove reality is far stranger than it looks. Science doesn't just exist in equations. It's happening all around us in ways that are totally mind-bending. And when you see them, reality starts to break. From light bending through space to materials that repair themselves, these are scientific phenomena you can actually see. First up, let's talk about black holes. We all know they're these cosmic vacuum cleaners, so dense that not even light can escape. But how do we see something that's invisible? The answer is we don't see the black hole itself. We see what it does to the space around it. Imagine a bowling ball on a trampoline. It creates a deep well. Now, roll a marble nearby. The marble's path curves as it gets closer to the bowling ball. That's exactly what a black hole does to light. This effect is called gravitational lensing. When light from a distant star or galaxy passes near a black hole, its path is bent by the intense gravity. From our perspective on Earth, it can look like the distant object is in a different place, or its image is stretched into arcs and rings, sometimes even creating multiple images of the same object. The Hubble Space Telescope has captured stunning images of these cosmic mirages, these so-called Einstein rings, which are direct, visual proof that these invisible giants are out there, warping the very fabric of spacetime. It's not a simulation, it's a photograph of gravity in action, a picture of a universal law playing out across billions of light years. And it's one of the most profound things you can witness. Next, have you ever seen lightning strike and thought, wow, that was fast? Well, what if I told you it's actually slower than you think, far slower? Your brain processes visual information so quickly that a lightning bolt seems instantaneous. But with high-speed cameras, we can slow it down and reveal what's really happening. A bolt of lightning isn't a single flash. It's a complex, multi-stage process. It starts with something called a stepped leader, an invisible channel of ionized air that zigs and zags its way down from the cloud, searching for the path of least resistance to the ground. It travels in short, 50-meter bursts, pausing for microseconds between each step. Once this leader gets close to the ground, an upward streamer of positive charge rises from the tallest object to meet it. When they connect, the circuit is complete. And that is when we see the return stroke, the brilliant flash of light that travels back up the channel to the cloud at nearly one-third the speed of light. But it doesn't stop there. Often, multiple return strokes, called a lightning flash, will follow the same path, which is why lightning appears to flicker. Seeing it slowed down 1,000 times is like watching a tree grow in reverse, with branches of pure energy reaching down from the heavens. It transforms a split-second event into a majestic, slow-motion ballet of physics. Now, let's make the invisible visible. We're surrounded by sound waves every moment of every day, but we never see them. We only hear them, or do we? There's a technique called Schlieren imaging that allows us to visualize changes in air density. And guess what sound is? It's a pressure wave, a traveling disturbance that compresses and rarefies the air. Using a special setup with a light source, a curved mirror, and a razor blade, scientists can make these pressure changes visible. When a sound is made, like a clap or a gunshot, you can literally watch the spherical shockwave expand outwards from the source, just like ripples in a pond. It's a perfect sphere of compressed air, a physical object moving through the room. You can see it reflect off surfaces, bend around objects, and interfere with other waves. It shows us that sound isn't just some abstract concept, it has a physical form. We're constantly swimming in an ocean of these invisible waves. Seeing them for the first time is like gaining a new sense, suddenly perceiving a hidden layer of reality that was there all along. It's a ghostly, beautiful, and absolutely real phenomenon. From the invisible to the seemingly impossible. Imagine scratching your phone screen and then watching the scratch just disappear, or a car bumper that mends its own dents after a minor collision. This isn't science fiction, it's the field of self-healing materials. Scientists are developing polymers and composites with the incredible ability to repair themselves. How does it work? There are a few different approaches. One popular method involves embedding tiny, microscopic capsules filled with a liquid healing agent into the material. When a crack forms, it ruptures these capsules, releasing the liquid. This liquid then flows into the crack and comes into contact with a catalyst agent that is also embedded in the material. The contact triggers a chemical reaction, polymerization, which hardens the liquid and essentially glues the crack shut, restoring the material's integrity. You can literally watch this happen under a microscope. A tiny fracture appears, a fluid seeps out, and the gap slowly fills in and solidifies until it's gone. It's like watching a wound heal on a non-living object. The potential applications are enormous, from longer-lasting infrastructure and electronics to safer airplanes that can repair minor damage mid-flight. It's chemistry imitating biology to make our world more resilient. Let's dive deeper into the world of the super slow. High-speed cameras don't just reveal the secrets of lightning. They unlock a whole new understanding of physics. Take the simple act of a drop of water hitting a surface. To our eyes, it's just a splash. But filmed at tens of thousands of frames per second, a breathtakingly complex drama unfolds. You see the drop flatten into a perfect pancake, then a beautiful crown-like structure erupts from the edges, with tiny droplets flying off each point. The central column of water then rebounds upwards, sometimes even forming a second, smaller droplet that pinches off the top. This is known as the Worthington jet. Every stage is governed by the intricate interplay of surface tension, momentum, and viscosity. Another amazing example is the Prince Rupert's drop. It's a tadpole-shaped piece of glass made by dripping molten glass into cold water. The head is so strong you can hit it with a hammer, but if you snip the delicate tail, the entire structure instantly shatters into a fine powder at over 4,000 miles per hour. Slow-motion footage reveals a crack propagating through the glass at incredible speed, a chain reaction of stored internal stress being released. Extreme slow motion doesn't just look cool. It allows us to see the fundamental forces of physics performing an intricate dance that is normally hidden from our perception. Finally, what if something could be a solid and a liquid at the same time? I'm not talking about a slushy, I'm talking about non-Newtonian fluids. These are bizarre substances that defy our everyday intuition about how liquids should behave. A normal, Newtonian fluid like water has a constant viscosity. It flows the same way no matter how much force you apply. But a non-Newtonian fluid changes its viscosity under stress. A great example is a simple mixture of cornstarch and water, sometimes called oobleck. If you slowly dip your hand into it, it acts like a liquid. Your hand sinks right in. But if you punch it, hit it with a hammer, or try to run across a pool of it, it instantly becomes hard as a solid. The sudden force locks the cornstarch particles together, dramatically increasing the viscosity and making it resist the impact. Then, as soon as the force is removed, it goes back to being a runny liquid. You can literally see the state change happen in real time. You can hold a solid lump of it in your hand and watch it melt and drip through your fingers the moment you relax your grip. It's a hands-on demonstration of some very complex rheology, proving that the lines we draw between states of matter are blurrier than we think. The universe doesn't behave the way we expect. And the more we discover, the stranger reality becomes. From the cosmic scale of gravitational lensing to the microscopic dance of self-healing polymers, these visible phenomena show us that there is a hidden world just beyond our normal perception. If this shocked you, watch the next video to have your mind bent even further. And subscribe for more scientific shocks. Thanks for watching.